Okay, we are going to be looking at code and particularly Rule 14100B. And so this is in regards to tap conductors that are less than 3 meters long. So a lot of the parts of this video are going to be spent on reviewing some previously learned concepts, and then we are going to focus on taps that are less than 3 meters long. So let's begin here. When we're looking at a splitter, so here we're looking at a splitter, and so we have a feeder coming into that splitter, and then we'll have smaller wires coming off, and they go to fusible disconnects, and then it would go out and feed our load. So anytime we reduce the size or ampacity of our wire, we have to put an overcurrent in. But we have special provisions that allow us not to put an overcurrent at the point where the wire size is reduced if we follow certain rules. And one of them is for these tap conductors or smaller wires that are less than 3 meters long. So here's a single line drawing of a splitter, and particularly we are focusing in today on right here where we terminate onto our splitter and to our first overcurrent, and the length of this wire when it's less than 3 meters long. So we don't have to put one right here, okay? We can put one within 3 meters if we apply these rules of 14100B. So feeder conductor is the feeder coming in, and then the tap conductors are the smaller conductor coming off from the splitter. Closer look at a splitter, what it would look like. So we see the larger conductor coming in right here. So that's our feeder. And then we have our splitter blocks. These are isolated, obviously, off of the case. And smaller conductors are coming off of these. And that would be our taps. Okay. So rules that this is a rule that allows us not to put an overcurrent right where the wire size is reduced, but somewhere along the first 3 meters. So how are they being protected? What is protecting the smaller tap conductors? Okay, so this is where 14100 comes in, and the purpose of this video is 14100B less than 3 meters. Now, in order to understand 14100B, we also have this chart, and this chart is not found in the code book, okay, and it is the size of fuses that you're installing and what size fuse holder rating that you would have to install. So purchase and install. So from 0.1 amp to 30 amp, I'd have to purchase a 30 amp fuse holder. So they'll fit in there. As soon as I get to 35 to 60 amp, I have to go up to a 60 amp fuse holder. 70 to 100, I'll have to go to a 100 amp fuse holder or fusible disconnect. Above 100 to 200, we're looking at a 200 amp. And then it keeps going up to 400 amp and 600 amp. So this is something you will have to commit to memory. It's not in your code book. It is in your ILM, but unfortunately you cannot use your ILM during an exam. And it's good to know too, if you have to order fusible disconnects, you know exactly what sizes they come in, and you can order the correct one. So it's 30, 60, 100, 200, 400, and 600. And there's an application that we have to follow. We have to know what size fuse holders that we need to purchase, as we have to size our tap conductor based off of the ampacity of that fusible disconnect. So I'm going to put up an example, and it's got a few things here going on. Recall once again, at any time in this video, I'm going to be referring to a lot of rules and tables as well. So you can pause this video at any time and go and review those rules or tables and look it up. Actually, I strongly urge you to do that. So in this scenario here, we've got our feeder coming in. It's protected by a 400 amp fuse, and the feeder coming in is 500 kcmil, which is good to 380 amps. For purposes of these examples, we are using copper conductors and table 2 for our ampacities. All equipment with termination temperatures of 75 degrees Celsius, and let's say we are also using R90 conductor, or 75 is fine as well. Okay. If so, recall back from, if you would like, review 4-006. That's termination temperatures. And so if we had a termination temperature less than 75 degrees, say 60 degrees Celsius, we'd have to size the ampacity of these wires based off the 60-degree termination. Or if we were using a insulation with 60 degrees Celsius insulation, we'd have to also use the 60-degree column in table 2 or 4 for this example. So 4 is for aluminum, 2 is for copper. All right, so we're going to come back and read this rule in a bit here, but let's do a quick little review. We're going to start on this 50 amp a non-continuous load over here, and we can size it all the way up and everything here, and then we'll review 14100B when it actually comes time to get to the tap conductor. So 50 amp non-continuous load, if we do a little review on that, that was covered in section 8, so 8-104, subrules 3, 4, and 5. And a load is considered a continuous load if it's on for more than 1 hour in any 2-hour time period and is less than 225 amps, or 3 hours in any 6-hour period and is more than 225 amps. So unless we can prove that it is not continuous, we would pretty much always assume it's a continuous load. So non-continuous loads are not nearly as common. So a dryer would be an example of a non-continuous load. So it's very specific, all right? And if you didn't know and you wanted to classify something as non-continuous, you'd have to be able to prove it, okay, that it's non-continuous. So when we have a continuous load, if you go back and review this rule, what it essentially says is that we can only load the circuit up to 80% of its rating. So both the circuit breaker and the ampacity of the conductors. So we only load that conductor up to 80% of its values in table 2 or 4, okay? And therefore, if we size our overcurrent based off of that conductor, we won't be loading up our circuit breaker past 80% either, okay? All right, so let's go on here. So a 50 amp non-continuous load. So if this is non-continuous, that means I can load that conductor up to its values in table 2 or 4 without doing any, derating that conductor essentially. So a 50 amp non-continuous load, if we go to table 2 and look up the 75-degree column, we would see that we would need a number 8. A number 8 would cover that 50 amp load. It is good to exactly 50 amps. All right. Now we need to protect this number 8 with a fuse right here. And so if we want to protect that number 8, we would look at rule 14-104. And I strongly urge you to go back and review 14104. Essentially what it says is that we size our overcurrent based on the ampacity of the conductor, where an overcurrent doesn't directly correspond with the ampacity of our conductor. We can use table 13 in order to determine that. And go ahead and have a look at table 13. Anyways, if you do that, we're going to see that we have a 50 amp fuse available. And so we would put in, we need a 50 amp fuse. Now for the 50 amp fuse, I need to size what size of disconnect to purchase or to install for that 50 amp fuse. If you recall back from the previous slide, the ranges for our fuse holders were 30 amp, and then it went to 60 amp, then to 100 amp. So the 60 amp would work just fine. So we'd purchase a 60 amp disconnect. Okay, so we are sized the whole branch here with the fuse as well as the disconnect. Now it's time to look at this tap conductor. In order to look at this tap conductor, let's go ahead and read rule 14100B all the way through. So it says all tap conductors from splitter are not longer than 3 meters. And why is that important? Well, there's 2 rules here for these tap conductor. One is for conductors not longer than 3 meters, which is rule B here in 14100. And then there's rule C, where they're not longer than 7.5 meters. After 7.5, you basically have to run the full size of feeder conductor all the way there. There's no more rules permitting. That's as long as you can go. So for us here, let's go ahead and read 14100B. So the smaller conductor has an ampacity not less than the combined computed loads of the circuit supplied by the smaller conductor, and not less than the ampere rating of the switchboard, panel board, or control device supplied by the smaller conductor. So that's very important, the switchboard, panel board, or control device. So our control device here is this fusible disconnect. That's our control device. So we have a 60 amp control device. All right. The other next rule here, item 2, is not over 3 meters. Item 3 does not extend beyond the switchboard, panel board, or control device that it supplies. So it's terminated in there. And item 4 is enclosed in a non-ventilated raceway armored cable, metal sheath cable, when not part of the wiring in the switchboard, panel board, or other control device. Okay, so this rule here, it says that we have to particularly stay focused on that we needed to install this 60 amp fuse holder. So we have to size this wire based off the size. It has to be at least cover the ampacity of the load. So number 8 for sure. But then the next part of it is that it has to be at least the ampacity of that fusible disconnect. So we have to size this tap conductor here at 60 amps. So if we go to table 2, 75-degree column, and look up 60 amp, we'd see we'd have to bump that up to a number 6. So our size of our tap conductor here from our splitter to our fusible disconnect is going to be a number 6. Okay, let's move on to the next example here. We have a 100 amp panel. Okay, now from the splitter to the circuit breaker termination, it is not longer than 3 meters. Okay, and it says that we have to, a panel is not considered a continuous load either for purposes of sizing feeders for panels. So all we have to do is size this based off the 100 amp panel. So if we go to table 2, we would see that under the 75-degree column, 100 amp, we'd require number 3s. Okay, next load here. We have a 60 amp continuous load. So we'd have to do a little bit of work with this first. So what this tells you is that we cannot load this branch circuit up farther or greater than 80%. So this conductor here cannot be loaded up any more than 80%. So what it's going to end up, if we did, it would heat up too much, and for continuously at 60 amp. So this conductor, the 60 amp load can only be 80% of the ampacity of this wire. So what do we do with that? We take our 60 amps, if you want to refer to 8-104 subrule 5A, that'll help you out with this. Okay, 60 amps divided by 80% or 0.8 gives us a minimum ampacity of 75 amps. So we could also multiply by 1.25. It's the same as dividing by 0.8. So the minimum ampacity of this conductor is 75 amps. So if I refer 75 amps, go to table 2, 75-degree column, and size that conductor, we would require number 4, which is good to 85 amps. So notice how I always put the 85 amps beside the number 4, what table 2's value is. We need that because that's the number, it's the ampacity of the wire that we have to size this fuse based off of. What's the maximum size fuse for this 85 amp wire, right? So 14104 again, same thing. So if 85 amp does not correspond to a standard rating of fuse, we can go to table 13. Table 13 would tell us we can go as high as a 90 amp fuse. All right. So I have a 90 amp fuse. I have to purchase a 100 amp disconnect here. So the size of this disconnect, remembering from the previous slide, is in the range. We have to go to a 100 amp disconnect. So now we look at this conductor, our tap conductor again. It has to be able to handle the load, so minimum 85, but it also has to have the ampacity of our control device that it terminates in. So that means we'd have to bump the size of this tap conductor up to, once again, table 2, 75-degree column, a number 3 to cover this 100 amps. Our last one here, we have a 200 amp panel. So this tap conductor is feeding a 200 amp panel, and it's got a 200 amp overcurrent right here. So because it's a panel, we can size this wire directly off of, so this is the control device, we can size this directly off of the 200 amp. So if I go to table 2, 75-degree column, look it up, we would need 3/0, which is good to exactly 200 amp. So that's the Table 2 is the copper, not more than 3 conductors. Okay, on the next video, I'm going to look at conductors greater than 3 meters, but not longer than 7.5 meters. We'll see you there.